very good afternoon to all of you. Today lecture is about the speeding the processor and improving Intel performance. Now, after we study the computer architecture from the beginning of the lectures, from the beginning of the semester up to now we have the idea how to improve the performance of the microprocessor by using pipelining. One of the lectures, another lecture is about using the hierarchy design, another lectures it was about the cache memory. So we have the three types of cache memory. So which type of cache memory you are going to use? As I mentioned, cache memory is the static RAM, or what we call it ROM, and also by the improving the speed of dynamic RAM as well, which is the RAM. Also, this is kind of improving the Intel performance. So all these types, how to improve the processor speed. Okay, so let me start with the today lecture. How do so first question we have: how did Intel speed its is a processor? Okay, so first think about pipelining. As you know, pipelining is is a technique that attempt to keep every part of the processor busy with some instruction. So by this it's going to improve the speed of the processor, of course. So the processor have each piece of a processor busy with some instruction. Is going to divide the tasks along the processor, so it will be very busy. By that will save lots of time. Also, another things which is onboard cache. This is a second way of speeding the processor. So what is onboard cache? Is a cache which is high speed data storage device, where a microprocessor stores that data used most often. Okay, integrated L1 and L2 cache. This is another technique to improve the speed of processor. So what is L1 and L2? This is memory typically integrated directly into central process unit chip. So the cache memory is responsible for speeding up computer operation and processing. Each core have dedicate L1 and L2. Okay, this integrated circuit. So this is going to make the memory full of information and instruction, and run the program fast. Okay, it will help the program to run fast. Okay, by dividing the cache into L1 and L2. Another way to speed the processor is by branch prediction. So you put a digital circuit, it tries to guess which branch will goes before. Okay, so it's going to take route of direction. It's going to see the fastest way, and that's whenever the microprocessor go to some address. So this is going to save the most recent open address. Okay, inside the room, and it will help to direct the processor. If the room is busy or full, is going to help the processor to direct to fastest way to reach to the address of the required things. Okay, so this is branch prediction. Data flow analysis is a technique for gathering information about possible values calculated at various various points in the computer program. So that's data flow. The last one, the last option to speed the processor is it's speculative technique or speculative execution. What is speculative execution? Is a technique used to optimize the system performance. So if the task not needed, it will delete it. It will avoid this task, or maybe the computer will require more programs or more resources. So it's going to take the right resources available. So this is going to calculate what is the minimum resources available for to make fast process and very fast. So this is speculative execution, one of the most evaluated technique, most important technique. They use it when design the Intel processor. Now all of you remember the Moore's law. The Moore's law, if you remember, that's the microprocessor speed increased twice every 1.5 years, and the RAM, ROM, hard disks, all these things, the size is going to increase twice every 10 years, almost every 10 years. So this is the principle of Moore's law, if you remember. So the hierarchy, the memory hierarchy principle of operation. So this is the principle of operation. So every 2 years the speed of a microprocessor increased to double, and the RAM, ROM, all these techniques, the memory size increased to double every 10 years. So why is suggested to solve the problems caused by the gap between logic memory and performance? As you see, the logic memory every 10 years increased to double, but the microprocessor every 2 years increased to double. So that makes big gap between the performance, the speed of the microprocessor, and the logic techniques which used, the size, the memory size. So there is a big gap. This is the processor memory gaps. So that's cause a problem. These are the problems. There are some suggestions to solve these problems for the gap. Okay. So what are these suggestions? One of these suggestions: an increased number of bit iterative at one time. So by making the dynamic RAM or random access memory, make it wider rather than deeper. So when you make it wider, you will have more size or more slots. When you have more slots coming from the motherboard to the RAM, so you will have more instruction, more information. So this is make it little bit more speed. So it's better. Change the dynamic RAM interface with cache. So this is one way also to decrease or to reduce the gap of which is between the logic memory and the speed of the processor. Reduce the frequency of memory access because the processor will be very high speed, and memory is considered memory speed is very slow comparing to the performance of the CPU, very high speed. So this is make problem. Maybe the memory, it will not catch the information which is coming from the processor because processor is too fast. So the one way is to reduce the frequency of memory access, but this is required more money because it need more complex cache and cache on chip. Okay, so very new technique. Okay, more complex technique, and that will cost more money. But this is it will solve the problem of this gap. So reducing the frequency of memory access and increase the interconnection bandwidth. So when you increase the bandwidth, you will get high speed bus. So high speed bus, high speed data address, data bus, address bus, or high speed controller. So that's to make when you get high speed for this, so this will catch up and will get the information from the processor which is faster, which is could be solution to this gap. And hierarchy bus. So this is increase the interconnection with the hierarchy buses. So these are the solutions. So there are 4 solutions to the problem of the which caused by the processor speed much higher than the memory speed. Okay, so that's solve the problem. By the way, what is the problem? I think I mentioned it. The problem is when you get higher processor, the memory speed is still low, cannot catch the information which is coming from the processor. So you may lose some information, and that's problem. So these are 4 suggestions to solve the problem. Okay, so that's for the other question. Another question: why suggested to solve a problem caused by gap between logic and input-output device of performance? So this is between the speed of the processor. Now between the logic, because logic is still as I mentioned, every 10 years is double, and input-output devices of performance. So either by caching, get high cache memory. Okay, so this is speed, the input output will be very high speed. Buffering, by putting buffer, by high speed interconnection paths, more elaborate bus structure, and multiple processor configuration. Okay, so these are suggestions or way to suggest for that, to solve that gap. Now, how do Intel improve the performance of Pentium family? There are 2 ways to improve the performance of Pentium family. One of them by increase the cache capacity. So when you increase the cache capacity, instead, for example, from 2 gigabyte, yes, the room make it maybe 4 gigabyte. So that's the cache memory will be very high capacity. It will better save, higher information. So as you know, because the cache memory is very close from the central processor unit, whenever the cache memory get bigger, so it's better, we make it more speed. Okay, the second way is by using more complex execution logic. Okay, so these are 2 ways. Maybe the first way is easier than the second way, but it will cost more money. Okay, by increasing cache capacity is easier than making complex execution logics for all the memories. So this is may cost, this is cheaper than this. Okay, but this is easier. This one, the first one, is easier than the second one. So typical, there are 2 or 3 level of cache memory, between processor and main memory. So first one, chip density increased. So how you increase the chip density? By making more cache memory chip. So you have 2 gigabyte room, cache memory 2 gigabyte. By the way, cache memory, when I'm talking about cache memory, I'm talking about room. or we call it static RAM, SRAM. Okay, so this SRAM, instead of 2 GB, you get another 2 GB to the computer. Of course, you cannot. This room is built in on the motherboard. You cannot build another 2 GB on the motherboard. So if you have, for example, 4 GB cache memory, so you should get, there are something like another 2 GB cache memory external, not internal. You cannot have internal another 2 GB. The room you cannot change it because it's built in. You could get extra room by getting external one. Okay, and that's costly. I think it's depend, first of all, if your computer have capacity to allow you to get another room, another extra room. Also, it's depend about the money. Maybe this will cost about $200 if you buy external cache memory, 2 GB, another 2 GB. That would may cost you $200, which is very expensive, because whole laptop you could get it in $600. See, so this is expensive. So by increasing the memory is not only that, it will get fast cache access as well. So the old one, the premium chip developed, the cache memory, it was developed 10%. Okay, the Pentium 4 developed about 50%. Now we are using in the market. If you go, there is Pentium Core i9. How much is developed? Just imagine. Okay, that's, I'm talking about Pentium 4. Now there is a Core i9 in the market. So how much is developed? How many percent? Now the computer is fast and powerful comparing to the previous years. See here? So more complex execution logic. Thus enable the parallel execution of instructions. The pipelining work like a simply line. So how the pipelining work? Pipelining, it's a different stage of execution of different instruction at the same time. Okay, so that's the pipelining, which makes the using the special logic to do this activity for pipelining. So that's make it much faster. See here. Also another way for more complex logic is superscalar. Use superscalar, which allows multiple pipelining within single process. See here. So if you use multiple pipelining with single process, so the operation will be very, very quick and very fast. Instructions that do not depend on one another can be executed in parallel. So as long as it will not interface, so it will be parallel. So if it's if it's interference between two tasks, so that's problem. So not that's pipelining. Pipelining, each task will be done alone. And when you do pipelining, so to make the processor busy, and by that you are going to save time for execution. So instead in operation you do it, for example, 1 hour or 2 hours, so you could do it in half hour or 15 minutes. See here? So that's all this by pipelining, solved by pipelining. One of the most important topics I explained before the midterm. Now that's it for today's lecture. Thank you for listening, and see you next week. Thanks. Bye.